Okay, so we are going to be looking at some systems of equations here, and you'll notice that both of the equations this time are in standard form, right? Same here. Now, the ones that we looked at before, we were solving by substitution. And the thing about substitution is that it's good whenever you have one of the variables kind of already by itself, whether it's x equals or if I can find one, yeah, or whether it's y equals. And what we did there was we would take the negative 2x plus 8 and substitute it in for y. All right, that way we could solve for x. Now, you can do that whenever they're in standard form, but you'd have to convert one of them to slope-intercept form first in order to do that. And a lot of times doing that, you would wind up with something messy, right? I have a little typo here. That's supposed to be a y. There we go. So I want to show you this other method. It's called the elimination method, but it's mostly used whenever the two lines that you're given are both in standard form. Okay, there's two basic cases. We're either going to add these two equations to cancel some variable out, or we're going to subtract the two. The thing you want to pay attention to are the coefficients here. Notice how this one has a 7 and that one has a 7. This one has a 6, that one has a 6. Whatever coefficients are quote unquote the same, those are going to be the ones that we try to cancel out somehow. So because these, we'll go ahead and do this equation first. Because these coefficients just differ by a plus minus sign, right? They're kind of opposites of each other. We're going to add the equations to cancel out this variable, right? So we're going to take these two equations and plus them together, and that's because one's minus and one's plus. So 10x plus negative 9x, that's just going to give you 1x. And then right here, the negative 7y plus the 7y are just going to cancel out. So that's going to be a 0. And then you're going to get 5 plus 5, so 10. So there we go. X is equal to 10. Now you'd still have to finish this off by taking your 10 and plugging it back into one of the equations to solve for y. So I'll use that top equation. So it's going to be 10 times 10 for x minus 7y equals 5. This would be 100 minus 7y. We would need to minus 100 from both sides. So this is going to give us negative 7y. And 5 minus 100 is negative 95. So y will equal 95 over 7, which doesn't divide evenly, right? So whatever that comes out to as a decimal, that would be our answer. Okay, we'll go ahead and we'll do this one. So this one, the x coefficients are a match. So to cancel them out, I'm not going to add them. I'm going to subtract them. If I added these two equations, this would give me 12x, and that would not be helping. It would be true, but not helping. Now, you could either do the bottom equation minus the top equation, or the top minus the bottom. It's totally up to you. I'll do the top minus the bottom. So 6x minus 6x is 0, and then it's going to be 5y minus 3y. That'll be 2y. And then we'll do the constant terms. It'll be 2 minus 10, which is negative 8. And then we'll divide by 2. So y is equal to negative 4. And then we got to take this answer and plug it into one of these two original equations. I'll go with the bottom equation. All right, we have 6x plus 3 times negative 4 equals 10. That's 6x minus 12 equals 10. And then we'll add 12 to both sides. So we get 6x equals 22. and then we'll divide by 6. So x is equal to 22 divided by 6, which is 11 over 3. Okay, there's a couple of examples, and I'll do another video with just more examples. That's the scheme. If the coefficients are the same, you will subtract the equations. If the coefficients are basically the same, but one's plus and one's minus, you'll add the two equations to cancel them out.